option just in case. And then, yeah. So for this one here, oh, I also posted graph paper for you to
Yeah,
access.
I have graph paper here.
Okay, yeah. So if you don't have graph paper, you at least have options here, different styles.
Okay.
Okay. So this is the actual instruction of the lab. So I'll click and download that. And then while that's downloading, I'll also click on the help math
Mm.
modeling. So I have both. Now one provides the instructions and then the other one provides just the help of how to complete the lab. Okay.
Yeah.
So let me see which is which. It's supposed to open once it downloads. Okay. Oh, this one here. No, I guess this one here. Oh, wait, hold on. Finally, that. Okay. It's taking a. My computer is slow today. I don't know why. I may have to reboot it because I
That's,
use it a lot.
I know.
Okay. So this is a help folder. So what I will do is open it, try to open it side by side so you can see.
Mm-hmm.
This is the
I,
help
yeah.
folder. You see that, right?
Yeah. Yeah.
And I'm
Yeah.
trying to find the one that has the directions. It's one of these. Okay. Let me make sure I copy the right one because they have the same name. I'm seeing the issue I have right now. I think this one here is what I'm trying to get. They have the same name.
Mm-hmm.
Okay, let's see. Okay, so this is the instructions, right? So this is telling you the lab is about graphing and math modeling. Then it tells you, it starts with the paragraph telling you about the axis. With every graph, you're going to have two axes, the y-axis and then the x-axis. The y-axis is vertical, a straight line going from up to down. The x-axis is horizontal, a straight line going from left to right. And then they meet. When they meet in the place called origin. So when you read this, it tells you all that. It gives you actual names like abscissa or x-axis. In chemistry, we tend to use just x-axis,
Mm-hmm.
y-axis. We don't use abscissa or ordinate. Those are more technical terms for math. So x-axis, up and down is the y-axis. So every graph has to have those points. Graphs where the x-axis will go further beyond the origin, it will continue left here like that. It
Mm-hmm.
depends on the data. The numbers they give you, if you have all positive x and all positive y, all you need is the vertical and then the horizontal and the origin. That's all.
Mm-hmm.
If you have negative numbers, then it has to go all the way this way. So let me
Yeah.
use the draw feature here to extend. Yeah, if you have negative numbers, it has to go this way. And
Mm-hmm.
sometimes they will tell you you have to draw beyond that. Then you go all the way like that. Okay? Remember,
Yeah.
the origin is where these meet. Then here, all they're doing is showing you examples of how to plot the graph. This is not your work. This is just an example. So they're showing you, for example, if you had a data set X and Y, and then here they already have the increments. The increments are these marks. You see the marks you have here? These
Yes.
marks, right? Let me use a brighter color. So red. These marks right here, these marks are the graduations, and the spaces between them, those are the increments. So
Uh-huh.
if you look at the marks we have here, we have 1, 2, 3, 4, 5. And since from the origin to here, this is a 1, that means in the origin, I'm assuming for the x-axis, it starts at 0. This point here is 0. And
Yeah.
then this is 1, then 2, then 3, then 4, then 5. So based on these marks, the graduation, the spaces between the value of the spaces between the marks, I would say for this one here will be 1. I don't know what the units are. They didn't say the units, so it's just 1, right? For
Mhm.
the y-axis, though, it looks different. It looks like there's a point here that's missing, right? I don't see it here. But if I were to put that back in and I made this
2.
2.0, right?
Yeah.
Then this, for the y-axis, this is also an origin. So we usually call that 0, comma 0, where the origin is 0 for x and 0 for y. So from the origin to the first mark is 2, right? And then the
Yeah.
second mark to the third mark is 2. So the spaces here or the increments is 2.
2.
So the increments is the value of the space. The increments. Sorry, I'm writing with my mouse, so I have
Yeah.
to write slowly. Increment, okay? 2. And here for the x-axis, the increment is 1.
1.
So somebody sent me an email. I don't know everybody yet. Somebody sent me an email saying, "Can the increment be different?" Yes, if you're using a different graph and you get to assign the increment. If you're using a different graph and you assign different increments, then they'll be different. They don't have to be the same from the x to the y axis.
Right.
You pick what you decide is best for your data set, right? So if you have these increments and these scales assigned, can you plot it? So they only plotted 1 point, right? They plotted this point here. I feel like there were more points. Oh, in the end, there were more points. But right now, they're only plotting 1. So the one that goes with 5 and 10, just to show you how to do it, right? So on the x axis, find 5. That's right here. 5 goes from here all the way up. Oops, I'm a little bit off, all the way up, right? It should go through the points they have, but you get the idea. 5 goes from here. I don't have any rule. I'm just using my free hand all
Yeah.
the way up. And then 10 goes from here all the way to the right. So the place where they intersect, where they overlap, they run into each other, that's where you put your point. And then if you want to label, which usually people do because it makes it easier to remember which is which, you always write the x first, then the y second. So the
Mhm.
x you used 5, the y you used 10. So 5 comma 10. That's the value of that point or the coordinates of that point.
Mhm. Yeah.
Okay. So once
Okay.
again, this is just teaching you. This is not telling you this is your graph. No, this is just telling you how to do that. Then
Right.
they're telling you once you plot all your points, I have 1, 2, 3, 4 here. I have 1, 2, 3, 4. They're showing you different types of graphs. Now I don't know why this one here moved, but if you look at this, I don't have a ruler and I don't know how to use a ruler in Word, but if you draw a straight line, you can find a straight line to go straight through these points here. Straight. Oops. Imagine that straight.
Mhm.
It goes
Yeah.
straight to the points, right? Because the line goes straight to the points, this is called error free. Somehow the line moved here. Error free meaning the points are all on the line. That's our goal. If we're going to draw a line, we want all the points to be on the line like that. So
Yeah.
none of them is off. But if you have a scenario like the one on the right, where this one here looks like the line will go through it, but this one is not through the line, neither is that, then this one here has errors. Where are the errors? The points where the line is not even going through them at all.
Mhm.
That's where your error is. Once again, this is just giving you background information. So when you read through that, it tells you that.
Okay.
And then here they're telling you how you will create a graph from a table of experimental data. So once you have data, how do you create a graph? So first thing they tell you, select a piece of graph paper and place the origin at the lower left corner. So here is where there's a little bit of a difference between what they wrote and what I did. Even though they have an origin, you see the origin here where it says 0. In mine, I don't have an origin. Okay.
Mhm.
So I'm now showing you what they're saying you should do, and then I'm showing you what I did. So I don't need this right here. So over here, even though I showed you what increments are, I start with this. This is my graph paper. And I selected my graph paper. That's this one here. And it says draw a set of coordinate axes originating from the origin. Well, I have my two axes. I have this x-axis and my y-axis. So you can say this is the origin, but it's not a true origin because when I later put my increments here, you will see this is not a real zero. Okay, so I'll talk about that. But
Yeah.
let me continue with that. So step one, done. I did that. I drew the axis. And then
Yeah.
it says label each axis. I did that. Temperature, degrees Fahrenheit. So let me scroll and tell you how I knew this was degrees Fahrenheit. When you scroll down here, this is your actual directions.
Yeah.
So when you scroll down here, it tells you obtain 3 sheets of graph paper. I'm only working with one first. Then it says prepare a separate graph for each set of data. Label the x-axis as temperature degrees Fahrenheit. That's how I knew temperature degrees Fahrenheit. So I wrote x-axis, temperature degrees Fahrenheit. I don't want to write x-axis here because that's known.
Mm-hmm.
So in doing this, I did both that first one and I did this. And then label the y-axis as relative humidity percent. I did that. So these 2 and 3 are done.
Okay.
But then they say plot, what's it called? Plot the graph for each set of data using the 2-point form. There's a lot more I have to do before I get here. This is where I need the other set of instructions. So I didn't write this, so I cannot move things around, but these instructions here help you to plot it. So then I'm going by this, right? So here I also have to have the title. They didn't say it, but you have to title your graph. So I put the title. For the most part, in the title, you write the x-axis, sorry, the y-axis versus the x-axis. So I made this short, percent relative humidity versus temperature. So just whatever label I have here, but I wrote it smaller. I mean, smaller. I shortened it, right? I didn't write all the words because I don't have a lot of space and I wanted to make my handwriting big so you can read it versus temperature. You can write temp or temperature, degrees
Yeah.
Fahrenheit. Okay.
Mm-hmm.
Now, to make it even easier, I would suggest for you and for me, since in the end you have 3 different, I know, I'm sorry I'm going back and forth, but it's necessary.
No,
Since you
yeah.
have 3 different dates, I didn't think of that when I was writing this. You want to include on here the date, 8, 13, 02. So you want to include that on here because once you draw your first one, you won't know, well, you will know which one you drew, right? But once you send it to me, I won't know which is which.
Yeah. So I need 3 graph paper, right?
Yes, 3 graph paper, one for this, right?
Yeah.
Oof, I'm writing in 2 places. One for
One
this, and
for
then the
this.
other one for this.
Okay.
Okay. So what I did here, I showed you the example for the peach color one, this one here. I use the same numbers. We don't do anything with the time. Your
Yeah.
X is temperature, your Y is percent relative humidity. So when I'm using the numbers, I'm using these exact numbers here.
So temperature is X and
Right.
RH is Y. Yeah.
Is Y. Yeah, it has to match this label here. This is
Yeah.
X, X, and this is Y, right?
Right.
Okay. So once I have that label, now I have to go back to what they were saying here because most of the work, the directions are here, but you just have to combine them. Okay, so we did this here.
Mm-hmm.
Now we have to know how to divide this, right? To know how to divide this is say, determine the range of X data. So the range is, the other word for range is how spread out your data is. Yeah, range helps you to know what value to assign the spaces. Okay, so how spread out it is. Like for example, just a random example. If you have data set going from 1 all the way to 10, you have a small range. If it goes from 1 to 100, you have a big range. That
Mm-hmm.
means the value inside the space has to be bigger,
Right.
right? So they're telling you here to figure out the range, take the maximum value, the biggest value you have, minus the smallest, and that gives you the range or the span or how spread out it is. Now, our numbers are not perfect like this. They're real data from the weather. So to do that, let me see. I want to leave the directions here. So I use that. Can I scoot this in? Yeah, let me see right here. Yeah. So I use your first set of data right here. The largest, because the range it says determine the range of the x data by subtracting the minimum value x from the maximum value. So our range for the x, oops, I need to do that. Range for x will be this subtracted from that. So the big one, that one here, minus the small one. So 88 minus 72. We should do that right here, right?
Yeah.
So 88 minus 72. So that's the range, okay? And then for the y range, this is the y right here. This is y, this is x. For the y range, I found the largest number, that's
90.
98. The smallest number is 68. So you subtract that. So just by looking at the range, regardless of how they're organized, the increments here, the spaces here have to be bigger because your data covers a lot more numbers, right? It goes a lot more wider, it's more spread out. So the increments here have to have a bigger value than the increments there, right?
Yeah.
So
Mm-hmm.
we have the range. So I can say, I did this, I did number three, I got the range. I did number four, I got the range of the Y data. Okay. Next, we have to figure out what's the increments. They say, calculate the value of the major units along the x-axis first, by dividing the x range by the number of increments between the origin and the x of the axis. Ooh, the end of the axis, right? So I have to remember this number. Let me write it down. I have a notebook here. 88 minus 72 equals 16. That's for the x-axis. The y-axis is 98 minus 68 equal 30. This is the y-axis. So now, mind you, this is based on my graph paper. Once you
Right.
have your graph paper, it might be different. So let me scoot this over to the right and make this bigger because I need to see this better. There. Okay. So on this right here, I think this will work. Let me make this a little thicker. Oh, that's too thick. Let me go back just a little bit. Okay. So here, these are my marks. So you have to mark your graph paper to figure out the number of increments. So I mark these big thick lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3. So these are the increments. At 10 plus 3, I have 13 increments. So this is for the x-axis, right?
Yeah.
Okay. So I have 13 increments. Okay. But they said they want me to find the value, the space between them. What's the space between here and here and here and here? To get that, I have to take the range I got. My range was what, 16, right? The
Yes.
range from earlier was 16. So I take 16 divided by 13.
Hmm.
Now I've worked this on later on, but I want to do it all on the same page so you can see. Then we'll scroll down and see how I did it later on. But that, yeah, so 16 divided by 13, and I get 1.23. Now here's the rule. You can use this number or you can round it up to an easier number. You don't want to round it down. If you round it down, then you won't be able to plot all your numbers in here. And
Okay.
if you round,
Can I use 150?
let's use 2. 2 is easier.
Oh yeah, 2 is
2 is
easier.
easier. Yeah, the 1.5 will work, but I think it'll be harder. 2 is a lot easier. Now,
Yeah.
if you use a very, very, very big number, it will make your graph very small. It will look like ants together. You don't want to do that. You want to use as much of your graph paper as possible. So we can use 2. So that means the space between from here to here is 2. From here to here is 2, 2,
Two,
2.
four, yeah.
Okay? So now we did that. So we did this one here, over here. This is done. I like to check things off. Oh, sorry. X is done. Now for Y. For Y, same thing. For Y, let me mark this here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's beginning to fade away. 13, 14, 15, 16, 17, 18, 19. Okay, so for my y-axis, I'll write it here so we don't confuse the two. For my y-axis, I made 19 increments. So I got 19 increments. But I want to know what the spaces between these increments are. What does the space stand for? What's the number? I take 19. And earlier, what did we do? Oh, sorry, it's the other way around. It's 30 divided by 19, right? Is the range, right? 30
30, yeah,
divided
divided
by
by
19.
19.
Because they say it right here by dividing the range by the number of increments. So just in case you forget, go back and read that. 30 divided by 19. What did I do? Oh, sorry. I'm leaning on my mouse. Let me go back and see. That will help. Okay, I'm here. Right. So over here, 30 divided by 19. Again, what do we get? 30 divided by 19. 1
150.
point, yeah, 1.57. Once again, this would be hard, right? So we
Yeah,
can round it up again to 2.
two.
You don't want to round it down because if you round it down, the graph paper will become too small and you tell me, well, I ran out of room. That means you round down. You have to round up. Okay? So we're
Yeah,
now at 6. 6 is done. So now they say number each major unit. So now we're going to number it. Okay?
yeah,
Now that we know the value, this all these spaces are 2 and this space is a 2. So our goal here is to make your zoomed in as much as possible. You don't want it to be so tiny and hard to see. So what we do here when it says number each plot, go back to the points you have, and then you want to start with the smallest point possible. For the x-axis, our smallest point was 72.
yeah,
So I'm going to show you on this paper. I've done it down here, but I'm doing it from scratch so you can see. So I'll show you on this paper how I do it. 72 was our smallest number, right? So
yeah.
let me erase this.
We start with 72 and 74.
Yes. And then you add 2 because that's the increment. 72 plus 2, 74. Ooh, my handwriting is bad. This is 76, 78, 80. If I can add 82, 84, 86. I'm running out of room, but you're going to be writing with it with your, so it'll be easier. 88. 90, right? 92.
94.
Oh, 94. 96. Okay. There. So you see
Yeah,
how that is, right? So you have all your points there. And then
yeah,
the same thing with the y-axis. Was it 68? Yep. 68. So we'll start with that.
yeah.
68,
8,
70,
yeah,
72, 74. So you see, it's not, once you know what you're doing, it's really not that bad, right? 76, 78. Ooh, I can't add. 80.
yeah. It's okay. I understand.
Right. So once you do all that, it makes if you pick a very good increment that you're comfortable with, it makes plotting so much easier and it goes so much quicker. So now that it says number each major unit, we just did that. Check. Done. Then it says now plot the X and Y data points. So now we are back to this direction here where it was saying plot the graph, right? So since I'm trying to do it side by side, let me have this here. I'll start with my first one. 83 from the X. Where's 83? This is 82, 84. That means 83 is somewhere in between here, right? 83 is
Mhm.
somewhere here. And that goes with 70 on the y-axis. So I go up here, 70, first point. This is done. Can mark that off. 82, 69. Line 82. 69 is halfway here. Plot that. Next. You see how much quicker it goes? When you pick your increments well, it goes real quick. 81, 70, wait, I lost my space. 76, 77 is halfway here. There. And so you keep going until you get all your points.
Yeah.
Until you plot everything. Since we
Okay.
picked the good increments, everything will fit. All these points here will fit. So let me
Okay.
show you then how I did that here. So this is that. So here's where I was showing you how I was getting the increments. I told you this is Y increment. This
Yeah.
is X increment, right? So now we
Yeah.
can scroll over all that. And then here's when I got the number, divide this
Yeah.
by that, and then this by that. So now it's all familiar, right? Then we
Yeah.
got two. Then here I labeled it. Then I labeled this down here. Graph just showing you the increments. Then here is my plot of the first one,
Yeah. Okay.
right? So I've done all the points. All the points fit here. And then here, now you have to draw the best fit line. So let me see if I can X this out. Now let me make this a little smaller. You have to draw your best fit line. Okay. The best fit line has to go with your data. What's your data doing? If you look at the data points here, let me go back here. It looks like it's kind of falling from the top left to the right like that. So
Uh-huh.
your line has to be in the same trend like this. Oh, can I write on here? No, it won't allow me to write. It has to go from top left to right down.
Mm-hmm.
Right. It can't go the opposite way because most of your points look like they're
Yeah.
falling from the top left to the right. Okay.
Yeah.
So
Okay.
here's when I drew my best fit line. Now
Okay.
the rule with the best fit line, this is supposed to be fit.
Mm.
Best fit line, it must, as I said here, it must follow the natural distribution of your data points. It cannot be against the data points. You want to make sure it has as many points here. The best fit line is similar to an average line that falls between your data points while passing through as many points as possible. If you look at this here, I can't even write. I don't think I can write on this. Oh,
One, two,
a little
three,
bit. Yeah,
five.
1, 2, 3, 4, 5. 5 points, right? This line, I try to make sure it passed through many points. I got 5 points to pass through the line. But after that, I have, let me use a different color, almost as many points above and below the line. Okay? So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 points above the line, and then 1, 2, 3, 4, 5, 6, 7, 8,
Okay.
9. I have 9 points below the line. It doesn't always work out evenly, but you want to get as many as possible on, yeah, you want the lines above and below to be almost, I mean, the points to be almost equal.
All right.
Sometimes it doesn't work out that way, sometimes it does, so that the line is almost dividing the points.
Mm-hmm.
So that way it's best fit. It takes a little bit of practice to get used to that. So what I do, I put my ruler with the thin end of the ruler facing down, then I count either side. If it's not working, I move it slightly to one side or the other until I get it to work. And then after that, you just plot the line. And they tell you here, you have to get the equation. Right. So once we're still on number 5, once we've drawn the graph, we've labeled, now it says write the equation on the graph. So how do we get the equation? We've plotted the line. How do we get the equation? Once you plot the line, you have to have the line. Pick any 2 points you want. You can only pick points on the line because remember, the ones above and below the line, those are errors. So of the 5, pick any 2. I picked this and I picked this. You write it again in the proper order. The x has to be written first. So if you look down here, this x is 80, the y
Mm-hmm.
is 82,
82, yeah.
right? Then for this one here, the x is 84, the y is 72.
Mm-hmm.
Okay? So it doesn't matter which one you select as one, pick any. I just wanted, because I wrote this first, I wrote this as x1, and then that makes this y1. They have to go together. You cannot say this is x1 and then y2. If this is x1, this has to be y1. And this one here will be x2, and this has to be y2. So you select, once you label it, x1, y1, and then x2, y2. So I have them selected and I wrote them here so I don't forget. You will use these numbers to get the slope of the equation of the line. So when you're done writing the equation of the line, the equation of the line of that best fit line will be in this format. It'll be y equal mx plus b. M has to be a number, which we are about to solve using these two here. And then B also has to be a number. They're specific. The slope tells you how much the line leans back, how much is angled. So it's a fixed number because it's the same lean from the beginning to the end. This B, the y-intercept, it tells you where this line cuts the y-axis. So if my graph kept going on here and this was a true origin, then I can tell where it cuts the y-axis. So it's just one number because it's only one point. So these two have to be one number. You will leave y as a variable. You leave y as the letter y and x as the letter x. Why? I mean, the question, why do you do that? Because if you see here, we have many x values and we have many y values, but we only have one slope and we only have one intercept. So
Mhm.
you don't put a number here for y or a number for x because which one will you pick? You have many to pick from. So you leave that as a variable like a letter y and leave this as a letter x. And then this has to be a number. This has to be a number. So here's where I show you how I get the slope m. So the slope m is equal to y2 minus y1 over x2 minus x1. I already have what they are from here, right? So I copy this down here. X1 was 80, Y1 was 82, X2 is 84 from here, Y2 is 72. Then I just plug them in the equation. Y2 is 72 minus 82, yeah, this and this. And then X2 is 84 minus 80. So once I do this, I get my slope. Some people like to leave it as a fraction. I like decimal point. So I get minus 2.4. That's my slope, my value of m. Okay. So far I have y equal minus 2.5. I just solved for this. X plus b. This is important. This is telling you how the line is sloping, but it's also telling you this is negative. Any line that has a negative slope, that means the line slopes backwards like that.
Mhm.
If it's positive, it slopes backward like this way. So anytime I look at your graph and it says negative, I'm like, okay, this matches that. If you say it's positive and you draw this, one of these is wrong.
Uh-huh.
Positive goes with that, right? Now we
Yeah.
have to solve for the y-intercept. For the y-intercept, I say you need your m, and you can pick any one. M has to go with either x1 and y1, or m can go with x2 and y2. But to make it easier, I just say just use m and x1 and y1. Just stick with that. It makes it easier. I know they worked it out here, back here. I just personally, I feel like this is complicated. Because if you walk away from this and you go to a different class, are you going to remember all of this? I don't remember that. It looks complicated to me. This is how I learned it in middle school. So I like that one when I was younger. I like this method better. It's simpler. Once you solve for m, use m and then one of the set. M and then x1, y1, and then plug them in there. What was x1? The same number, 80 here. What is y1? 82. So I put 82 here. But remember, these are multiplied, not added, right? So
Yeah.
m is negative 2.5 times 80 That gives me negative 200 plus b, and this is 82. Now we're trying to solve for b. Since these here are added, you can't just divide. Since this is negative 200, you have to add 200. Add 200. You want to get rid of this. So if it's negative 200, add 200, this becomes 0.
Yeah.
0 plus b is just going to be b. Then add 200 here, we get 282, b. So this is now b. I plug in my m and my b in the equation, and I tell you this is my equation of the line. So for you guys, you will write this negative 2.5. Where is that? You write it here, negative 2.5x plus 282. Oh, don't forget y equals, because the equation must have all those parts to be recognized as an equation. Some people write it like this: m equal negative 2.5 and then b equal 282. This is not the equation of the line. That's the equation of the line. That's the format that's recognized. This is just numbers.
Okay.
Yeah, so it has to be in this format here. So this is just number. This is not the correct answer. And then they ask you, so let me go back to the directions. They say clearly label each graph as to which data it refers to. So we did that, right? Write the equation on the graph. We just did that. Then number 6, it said from an examination of the graph, look at the graph and the equation, formulate a hypothesis about, wait, are there more words? Wait, what? There are words missing here. Okay, it's supposed to you're supposed to relate the y-axis to the x-axis. So I actually wrote this here. Sorry about that. I hope your book has this complete. Somehow the one I posted here is missing some words. But this is my formulation, my hypotheses, based on the graph. In chemistry, we use a graph to relate two measurements. So if you have one measurement and another, you use the graph for that purpose. We want to know, how does one measurement influence the other? Okay, so once we've drawn the graph, I'm going to sketch it here. It looks like this with a negative slope. How is relative humidity related to temperature? Based on what we see on the graph and the equation, right, which has a negative slope, we can say when the temperature is increased, if you look at this, low temperature, high relative humidity, high temperature, low relative humidity. When you increase the temperature, go from low to high, the percent relative humidity decreases. It's opposite, inversely related. But this is my hypothesis. This is my answer to question number 6.
Mm-hmm.
Yeah. So when
Okay.
temperature increases, the relative humidity decreases. So remember, in
So,
chemistry, the purpose of the graph is to relate two measurements that may or may not be related. Now we can see here, these are related and we can see how. You were asking something?
yeah, so I submit 3 graph paper and 3 of those paper, right?
Right. So you have one of these statements for every graph. Yeah. So this is your first one. You do 2 more, but you have to submit all 3. Even though I've done the first one for you, you have to draw your own and report your numbers, because remember, my numbers are based on the graph I use. The
Yeah,
number, if you have a different graph, your number will be slightly different. It's not wrong. It's just based on the graph you use.
right. And okay, I understand. Thank you so much for your time,
Okay.
Dr. White. And I have another question. I have a calculator.
Mhm.
I got it last semester for this one is my calculator. Can I use it for chemistry too?
Okay, hold on just a second. Let me find the screen.
And that's statistic calculator.
You maybe. I mean, oof, sorry. Now I'm trying to find the screen where. What type is it?
It's TI 84 plus.
Oh yeah, yeah. You can use it. Hold on. Let me try to find the screen. I'm trying to find the screen that has a collaborate. Hold on just a second. I think it's the one with the orange. This one here. Oh, yeah, there. Okay, now I can see. Yeah, yes, yes, you can use that.
Okay, and when I